Hi students, welcome to DSR Maths. Today's our topic is domain of a function. In that, especially we have to find the domain of a function which is involving logarithmic function. So in that, take the first problem. Find the domain of f of x equal to root of log of x minus 1 by x plus 5 to the base 0.4. To find the domain of this function, we should know some rules. In the last video, that rules we discussed. So what is that? In that, see, root of f of x is there means this f of x is definitely greater than or equal to 0, right? And whenever log of f of x to the base g of x is there means this f of x is greater than or equal to greater than 0, and this g of x is greater than 0, g of x not equal to 1. So according to that we have to simplify this one. Now this function f of x is defined when it is defined if first one, so under root value, that is log of x minus 1 by x plus 5 to the base 0.4 greater than or equal to 0. This is the first condition. And what is the second condition? That is log of f of x, means this f of x, x minus 1 by x plus 5 greater than 0. And g of x is greater than 0 and it is not equal to 1, right? Now, so from this one we have to find x value, from this one also we have to find x value, and we have to take the common values of these two, that is our required domain. For that, so here to simplify this one, again we have to take this condition. We know that whenever log x to the base a greater than or equal to k is there and a is in between 0 to 1, so x can be written as what? This inequality will change. Greater than or equal to becomes less than or equal to a power k when 0 less than a less than 1. By that condition, this can be written as, that implies x minus 1 by x plus 5 less than or equal to 0.4 whole to the power of 0. That implies x minus 1 by x plus 5 less than or equal to, this is 1. Next, this one is as it is, and x minus 1 by x plus 5 greater than 0. So here also same thing, x minus 1 by x plus 5 greater than 0. Now, so take this one. So this one, take this side, x minus 1 by x plus 5 minus 1 less than or equal to 0. That implies, take the LCM, x plus 5. So here x minus 1 minus x minus 5 less than or equal to 0. That implies minus 6 by x plus 5 less than or equal to 0. This is the first condition. Next, second one, and what is there? X minus 1 by x plus 5 greater than 0. So from this one, x values we have to find. Take the number line. What is the critical point here? Minus 5. Any value substitute less than minus 5. So here less than minus 5 means minus 6. If I substitute minus 6 plus 5 negative, and minus 6 means like this, minus 6 by less than minus 5, minus 6 you substitute, minus 6 plus 5. Here also negative, here also negative. Negative by negative, it has what? Positive. And greater than, this one you substitute, x equal to minus 4 you substitute, minus 6 by minus 4 plus 5, that is equal to minus 6 by 1. So this is positive, sorry, negative. So it is positive and it is negative. So what we want, x, whenever this condition is less than or equal to 0 you want. So that's why what we have to take, x belongs to this side, means minus closed interval also you can take, because here less than or equal to there. So x belongs to closed interval minus 5 to infinity. Now from this one also you take the number line. So take the critical points, here minus 5, here 1. Less than minus 5, one value substitute, x equal to minus 6 you substitute, minus 6 minus 1 by minus 6 plus 5. So negative by negative, here positive you will get. Next, between these two, 0 you substitute, here negative getting. greater than 1, 2 you substitute, it is positive. But this condition when greater than 0, this function when greater than 0, that condition we have to take. Now greater than 0 means this one and this one. Means here x belongs to minus infinity to open interval minus 5. Because here strictly greater than 0 is there. Union here 1 to infinity. Right? So take this as equation number 1 and this as equation number 2. 1 intersection 2 you have to take. Then that is our required domain. So for that again you take the number line. So minus 5 and 1 here infinity. So this is closed interval minus 5 to infinity. Means closed interval minus 5 to infinity. And this one is minus infinity to minus 5. Minus infinity to minus 5. Open interval this side. Next 1 to infinity. This is 1 to infinity. So in these two, what is the common values? Common area is here to up to infinity. Means x belongs to. So open interval 1 to infinity. So this is our required what? Domain of the given function. Right? For that what you taken? See, this is under root value greater than or equal to 0 and log of f of x greater than 0. From this one, x values means x where so this condition is exist minus infinity, minus 5 to infinity. And from this one also x values you taken, that is minus infinity to minus 5 union 1 to infinity. Again common values of these two, because the value of x which one you are taking, that is satisfies the given equation, means given function. So that's why our required domain is x belongs to open interval 1 to infinity. Right? This is final answer. Next, second problem we will take. Second one. F of x equal to log of log x to the base 10 to the base 10 to the base 10, here also to the base 10 is there. So how to do this one? So this is also important one. Listen carefully. Here also we know that log x to the base a is there, means here what? X greater than 0. Or log of f of x to the base g of x is there, means here this is greater than 0, this is also greater than 0 and g of x not equal to 1. Here also a greater than 0, a not equal to 1. By that information we have to take here also some conditions. So this function f of x exists. When it is exist? F. So here if you treat log of this total as x or f of x, the here to here you take it as f of x. Definitely it is what? Greater than 0. Log of f of x to the base g of x. Means this total is f of x. Means log x to the base 10 to the base 10 to the base 10. It is greater than 0. Log of f of x greater than 0. And here f of x means this is also x, f of x only. Means here also x greater than 0. These two conditions. Now here again, so if you treat this as log of f of x, so we can write it as log x to the base a greater than k, means x greater than a power k, because here a is 10 greater than what? 0 is there, and greater than a is greater than 1 is there, because we know that log x to the base a greater than k, x greater than a power k when a greater than 1. So that's why. And now how to write by that one? It can be written as, if you treat this as x, log x to the base 10, here also to the base 10, greater than 10 to the power of 0. That implies log x to the base 10, here also to the base 10, greater than 10 to the power of 0 is 1. Now again you treat this as x, means it can be written as log x to the base 10 greater than 10 to the power of 1. Again you treat this as what log x to the base 10 means x can be written as 10 to the power of 10. And what is there? X greater than 0 is there, right? So take this as equation number 1 and this as equation number 2. So 1 intersection 2. This is greater than 0, this is greater than 10 power 10. What is the common area? So definitely x belongs to 10 to the power of 10 to what? Infinity, right? Suppose if you take it as 0, here anywhere 10 to the power of 10 if you take. So this is greater than 0 and this is greater than 10 to the power of 10 means like this. What is the common area? Here to here only. So like this we have to do. So means x belongs to domain of the given function is what? 10 to the power of 10 to infinity. Okay, no? So for this what you taken? This one as f of x means f of x greater than 0 because it is in the form of log of f of x greater than 0. And again here also x greater than 0. Here x greater than 0 then only it is exist. So these two conditions. So for, after that simultaneously log of f of x greater than a to the base a means log x to the base a greater than k means x greater than a power k we applied so these 3 times. Then x greater than 10 power 10 you got. So after that x belongs to 10 power 10 to infinity, right? So this is about the second problem. Next we'll do the third problem that is also involving the logarithmic function only. Third problem. F of x equal to log of 18x minus x square minus 77 here to the base 3 to the base 5 to the base 4. So this is also like previous problem only. Log here 3 5 4 18x minus x square minus 77. Now here also same thing. What we have to take? This should be greater than 0. And if you treat this total as f of x, that f of x is what? Greater than 0. Means this function f of x exists. When it is exist, f this total function should be greater than 0. Means log of 18x minus x square minus 77 to the base 3 here to the base 5 greater than 0. And the second one is what? This one 18x minus x square minus 77 greater than 0. When these two greater than 0 then only this function exists, right? Now after that the same like previous problem simultaneously we have to simplify. Now here to here if you take as x, so it is in the form of log x to the base a equal to k. Here a is greater than 1. So that's why what we can take it as log of 18x minus x square minus 77 to the base 3 greater than 5 power 0. Now that implies log of 18x minus x square minus 77 to the base 3 greater than 5 power 0 is 1. Again log x to the base a equal to k form, here a greater than 1. Again it can be written as 18x minus x square minus 77 greater than 3 power 1, right? Now here also and this is as it is. Multiply with minus here. X square minus 18x plus 77 less than 0 is there. And if you take the factors for this one, what are the factors? X minus 7 into x minus 11. 11 into 7 less than 0. And this can be written as if you take a number real number line. So what we will get? Otherwise we know that x minus alpha, x minus beta less than 0 means alpha less than beta less than x less than beta. If alpha less than beta, alpha less than x less than beta. By that condition, how to write? 7 less than x less than 11. So take this as equation number 2. Now if you simplify this one. So 18x minus x square minus 77. Bring this side. Minus 3 greater than 0. 18x minus x square minus 80 greater than 0. Multiply with minus. X square minus 18x plus 80 less than 0. If you multiply with minus, greater than becomes less than. Now what are the factors here also? So x minus 8 into x minus 10 less than 0. Here also it is in the form of what? X minus alpha, x minus beta less than 0. It can be written as 8 less than x less than 10. Take this as equation number 1. This as this continuation. Now here for getting the domain of the given function, what we have to take? Common values of these two, right? Now for that, 1 intersection 2 we have to take. So these two take on a real number line, then easily you can identify the what? Common values. So first one is here 7, 8, 10 and 11. So this one is 7 to 11. Open interval 7 to 11. And this one is open interval 8 to 10. So like this. What is the common area? This is the common area. So x belongs to 8 to 10. So this is the domain of the given function, right? So this is about the third problem, right? Next, fourth problem, that is also a function which is involving logarithmic function. Right. Fourth problem, f of x equal to log of x plus 3 to the base 2 divided by x square plus 3x plus 2. So domain of this, find the domain of this function. See here, this here also f of x is defined. When it is defined, if this numerator, in this numerator, definitely x plus 3 greater than 0 only, no? Because it is in the form of log of f of x to the base g of x, no? Here g of x is greater than 0 and which is not equal to 1. So here f of x greater than 0 means x is greater than minus 3. Take this as equation number 1. And denominator is what? X square plus 3x plus 2. Definitely it is not equal to 0. Then only this function is exist. What are the factors for this one? X plus 1, x plus 2 not equal to 0. Means x not equal to minus 2, minus 1. Means all the values which are greater than minus 3 except minus 2, minus 1. Means from these two, what we can write? X belongs to minus x greater than minus 3. Greater than minus 3 means minus 3 to infinity except to minus 2 comma minus 1, right? All the values which are greater than minus 3 means here minus 3, greater than minus 3, in between minus 2 and minus 1 we can't take, right? This is our required domain of the given function. So this is about the fourth problem. And take the fifth problem. So all these problems are most important in this chapter. So especially finding the domain is most important concept. So f of x equal to 1 by root of log of x square minus 7x plus 13 to the base 1 by 2. So once you see all these functions involving logarithmic function only and different types problems. So here also we know that 1 by root of f of x is there means f of x greater than 0, not equal to 0 because it is in denominator, right? Next again log of f of x means f of x is greater than 0, right? Now by that conditions, from that rules what we can write? This function is defined. When it is defined, if first condition is log of x square minus 7x plus 13 to the base 1 by 2 greater than 0. First one is it is greater than 0. And the second one what we have to take? log of f of x means x square minus 7x plus 13, it should be greater than 0. From this one x values, and common values of the 2 is the required domain. So for that, what we have to simplify here, 1 by 2 means log x to the base a greater than k. Here a is in between 0 to 1 means x is less than a power k whenever a between 0 to 1. Now from that condition, what we can write it as x square minus 7x plus 13. This greater than becomes less than 1 by 2 whole power 0. Right? Now that implies x square minus 7x plus 13 less than 1 by 2 whole power 0 is 1. That implies x square minus 7x, bring this side, plus 12 less than 0. Now here and so if you take the condition, so what is the condition when it is greater than 0? We know that from this one also ax square plus bx plus c greater than 0 for all x belongs to real numbers. So if a greater than 0 and discriminant b square minus 4ac less than 0 or not, is it satisfying this condition once you observe? See b square minus 4ac, b square is minus 7 whole square means 49 minus 4 a c is 13, definitely it is less than 0, and a equal to 1 which is greater than 0 means this quadratic equation satisfying this condition means definitely it is greater than 0 for all x belongs to real number only or not, right? Now for all x belongs to real number, this is exist. Next come to this one. Now this has x minus 3 into x minus 4 less than 0. Can you write? If you take the factors this one. Now this can be written as 3 less than x less than 4. This has equation number 1. Now from 1 and 2, what we can write, tell me? This is exist between 3 and 4. This is exist for all the x belongs to real number. How we are identifying this is exist for all the real numbers? Because we have this condition. Otherwise, from this one also you can take like this. Suppose x square minus 2 into 7 by 2 into x plus 49 by 4 minus 49 by 4 plus 13. So multiply and divide by 2 for this one. So it is in the form of a square minus 2ab. So 2ab means what is missing? This is missing. So that's why b square minus b square. From these three, what we can write? X minus 7 by 2 whole square. And if you simplify, this is minus 49 by 4. Here 49 by 4 plus 13. So here what we can write? Plus 52 minus 49 means 3 by 4. Definitely it is greater than 0 only or not. For any value of x, this is square is there means it starts from 0 plus 3 by 4 means it is greater than 0 means it is positive for all the real numbers. Any real number you take, it is greater than 0 only. Like that also you can identify, right? And now from these two, so what is the common values of these two? 1 intersection 2 is what? This one only. So that is x belongs to open interval 3 by 4. So this is what? Our required solution of the means required domain of the given function, right? In nothing but from these two, any values if you substitute, this function satisfies. So that is called what? Domain of the given function. Okay, no? See the sixth problem. In this one when it is exist, once you observe, 1 by f of x form is there and log of 1 minus x is there. We know that 1 minus x should be greater than 0 and 1 minus x not equal to 1, because if you take it as 1, log 1 0, 1 by 0 not defined, and this one and x plus 2 greater than or equal to 0. Now here 1 greater than x, that implies x is less than 1, and from this one x not equal to 0. and here x is greater than or equal to minus 2. So these three take on real number line. So this has 0 and here minus 2, here plus 1. So it is greater than or equal to minus 2. So from here, and in this one x not equal to 0 and x less than 1. So what is the common area? Here to here, in this one 0 does not exist. So therefore x belongs to closed interval minus 2 to open interval 0, because here we can't take this 0, union 0 to open interval 1. So this is our required domain of the given function, right? Next, so take the seventh problem. So seventh problem also involving the logarithmic function, a function which is involving logarithmic function, that is f of x equal to log of here x minus 3 to the base x minus 3 x square minus 3x plus 2. F of x equal to log of x square minus 3x plus 2 to the base x minus 3. So what are the conditions? It is in the form of log f of x to the base g of x. F of x exists if x square minus 3x plus 2 greater than 0 and g of x greater than 0, g of x not equal to 1. Now from this one, if you take the factors x minus 1, x minus 2 greater than 0, and from this one x is greater than 3. Now in this one again x not equal to 4. If you take x equal to 4, 4 minus 1 to the base means in place of g of x 1 does not exist, right? So here x minus alpha, x minus beta greater than 0 means how to write it as x less than 1 or x greater than 2. So this one equation number 1, 2, 3, these three take on real number line. So here 1, 2, 3, 4. In this one 4 we can't take. So greater than 3. So this is greater than 3. Next x less than 1. So less than 1. And x greater than 2. So this is greater than 2. So what is the common values in this? Here x belongs to, here common values not there, from here it will start, but in this one 4 we can't take. So that's why open interval 3 to 4 union 4 to infinity. These are the common values of 1, 2, 3, right? So this is our required domain of the given function. From where to where? 3 to 4 open interval union 4 to infinity. So right? So this is about the seventh problem. Now take the eighth problem also. That is eighth one. F of x equal to log of 2 log x to the base 10 plus 1 divided by minus x to the base 100x. Listen carefully. So this is also like a previous problem, but function is different. So here also this function f of x exists. When it is exist, if this one greater than 0 means 2 log x to the base 10 plus 1 divided by minus x, it is greater than 0. And this g of x is 100x not equal to 0. Next this 100x not equal to 1 also. G of x greater than 0. G of x is greater than 0 and g of x not equal to 1. So g of x greater than 0 means x greater than 0. 100 into x, 100 is already greater than 0 means this one greater than 0. Now here x not equal to 1 by 100 also. Next here once you observe x is greater than 0. means whatever the minus x less than 0. Once you observe here carefully, it is positive, means greater than 0. But already minus x is what? Less than 0. Means when you will get this right side is positive, numerator is positive, denominator is positive, means greater than 0 you will get. Or numerator is negative, denominator is negative, means greater than 0 you will get. But we know that minus x is greater than 0 or minus x is less than 0, means denominator is less than 0, means definitely numerator also less than 0, means this is negative, then only positive will get. So that's why, so 2 log x to the base 10 plus 1 less than 0, since this is the reason, right? Now that implies log x to the base 10 less than minus 1 by 2. X is less than 10 to the power of minus 1 by 2, since 10 is greater than 1, right? And now here x is less than 10 to the power of minus 1 and minus here x greater than 0. Next here x not equal to 10 to the power of minus 2. These three we have to take on real number line. So that as here 0 and here you take 10 to the power of minus 2, here you will get, suppose if you take this as 10 to the power of minus 1 by 2. So it is less than minus 1 by 2. Less than minus 1 by 2 means this side you will get. Next here 0, x greater than 0 means this side you will get. Next in this one, which one we can't take 10 to the power of minus 2. So here this one we can't take. So now what is the final answer? Here to here, grade 0 to x belongs to 0 to 10 to the power of minus 2. Union 10 to the power of minus 2 to 10 to the power of minus 1 by 2. Once again listen here. X less than minus 1 by 2. So this side. In the next term, x greater than 0. This is x greater than 0. But in this x to the power of 10 to the power of minus 2 we can't take, right? Now, so where to where? 0 to 10 to the power of minus 2 union 10 to the power of minus 2 to 10 to the power of minus 1 by 2. This is our required domain of the given function, right? So this is about the 8th problem. Next we will take the one more problem. So all these are functions involving logarithmic function, different types. Next one. Ninth problem. F of x equal to log x square minus 8x plus 23 to the base mod sin x minus 3 by log of mod sin x to the base 2, right? And now listen carefully. This has log x, if you treat, this should be greater than 0, right? Now, so what they given here? Log of this one means log of x square minus 8x plus 23 to the base mod sin x minus 3 by log of mod sin x to the base 2 greater than 0 we have to take, right? Now it is greater than 0. Now again it can be written as log of x square minus 8x plus 23. You can write to the base mod sin x minus, can you write this as 3 into log of, so we know that log a to the base b can be written as 1 by log b to the base a. Can you write? Now by that one I will write it as log 2 to the base mod sin x. Can you write it as greater than 0? Now that implies log of x square minus 8x plus 23 to to the base mod sin x minus this one 2 to the power of 3 means log 8 to the base mod sin x greater than 0. Again log a minus log b. Log a minus log b. Log a by b you can write. That implies log of x square minus 8x plus 23 divided by 8 to the base mod sin x greater than 0. We know that mod sin x is between 0 to 1 and including 0 and 1 means it is closed interval 0 to 1. It belongs to what? Closed interval 0 to 1. So that's why if you take x square minus 8x plus 23 divided by 8 greater than mod sin x whole to the power of 0. That implies x square minus 8x plus 23 greater than, here this is 1, so 8. X square minus 8x plus 15 greater than 0. This is one of the condition. And also we have to observe, see, it is in the form of f log of f of x to the base g of x, right? But modulus of g of x is there. So we taken some rules. So modulus of f of log of f of x to the base g of x means this f of x is greater than 0. G of x is what? Belongs to real numbers except minus 1, 0, plus 1. Because if you take 0 here 0, it does not allow 0, and 1 also. Modulus of minus 1 plus 1 also you will get. So that's why all the real numbers means here sin x, this is important condition, sin x not equal to minus 1, 0, plus 1. So definitely that one we have to take, right? Because in place of g of x what is there? Mod sin x is there. So sin x does not allows for this one minus 1, 0 and plus 1. Means nothing but x not equal to n pi and 2n plus 1 into pi by 2. N belongs to integers because n equal to pi 0, n equal to 0, 0, n equal to 2 pi 0 and n equal to pi by 2 1, n equal to 3 pi by 2 minus 1 like that. So that's why x not equal to n pi and 2n plus 1 into pi by 2 where n belongs to integers, right? And now here if you simplify this one, so bring this side. So x square, so here this is 0 to 1 means this greater than becomes what? Less than. Here also less than. So here also less than because it is in between 0 to 1. Now x square minus 8x plus 15 less than 0. What are the factors? X minus 3, x minus 5 less than 0. 3 less than x less than 5. And x not equal to, in between what are the values from this one we can take? X not equal to pi and 3 pi by 2 by using the what real number line. If you take in this one, so between 3 and 5 what are the values exist from this one? X equal to pi and 3 pi by 2. And now so if you take these values, here 3 and here 5 is there means pi means 3.14 here anywhere, and this is also means between these two this one and this one does not exist. So that's why final answer what we have to take, x belongs to, so x is between 3 to 5, but in this pi and 3 pi by 2 we can't take because x not equal to n pi and 2n plus 1 by 2. Now x belongs to 3 to pi union pi to 3 pi by 2 union 3 pi by 2 to 5. This is our required domain of the given function. See the 10th problem. So this is an important problem. Listen carefully. Here what are the given? Root of f of x is there. First what we have to take? Log of x minus 1 to the base 0.3 divided by x square minus 2x minus 8. It is greater than or equal to 0. And this log is there means here x minus 1 greater than 0, x is greater than 1. Take this as equation number 1 like this. Okay, x is greater than 1, right? Now here come to this one. In this one there are two cases. Once you listen carefully. In the case 1, so when it is greater than or equal to 0, this is greater than, this is positive, this is positive. Means log of x minus 1 to the base 3 greater than or equal to 0 and x square minus 2x minus 8 greater than 0. Right? It is not equal to 0 because it is in denominator, but it may be equal to 0 because here equal to 0 is there, right? So first case means when this is greater than or equal to 0, this is positive means greater than or equal to 0, this is negative means also greater than or equal to 0, like that you have to take. Next, in case 2, what we have to take? Log of x minus 1 to the base 0.3 less than or equal to 0, means it is equal to also there, maybe it is 0. And second one, and denominator x square minus 2x minus 8 less than 0. Listen, less than or equal to 0 by less than means negative by negative. What? Positive and greater than or equal to 0, and greater than or equal to 0 by greater than means greater than or equal to 0. In these two cases we have to find x values with x greater than 1. So first take the case 1. So in case 1, what you taken from this one? So here log f of x to the base g of x greater than or equal to 0, 0, here g of x is between 0 to 1, means here x minus 1 less than, this greater than or equal to becomes less than or equal to 0.3 whole to the power of 0. That implies x minus 1 less than or equal to 1. That implies x less than or equal to 2. Right? Next, and this one. And x square minus 2x minus 8 greater than 0. Take the factors x minus 4, x plus 2 greater than 0, right? Right. So it is greater than 0 means x less than minus 2 or x greater than 4. So for these two intersection we have to take. So for that take the real number line, that is here minus 2 and here 2, here 4. So first less than minus 2 and greater than 4, and here greater than or equal to 2, less than or equal to 2, less than or equal to 2. Common values, these are the common values, means here x belongs to, so here x belongs to what? The here to here, minus infinity to minus 2. So take this as equation number 1 by the case 1, right? Next, case 2 you take. So what is the case 2 here? From this one, here also 0.3 between 0 and 1, means x minus 1 greater than or equal to, this less than or equal to becomes greater than or equal to 0.3 whole power 0. So x minus 1 greater than or equal to 1, x greater than or equal to 2. So next, and what is there? This one, x square minus 2x minus 8 less than 0 is there. Now here also if you take the factors x minus 4 into x plus 2 less than 0. So minus 2 less than x less than 4. So for these two, what we have to take? Intersection we have to take. So that is, if you take the intersection, so here you take equation number A. Now this is from the basic function, main function. So these two common area, from these two intersection we have to take. This is minus 2 plus 2, 4 greater than or equal to 2. Next minus 2 to open interval minus 2 to minus 4, right? What is the common area? X belongs to closed interval 2 to open interval 4, right? This is x belongs to closed interval 2 to open interval 4. So here take this as equation number 2. This is by case 1, this is by case 2. So for these two union we have to take, listen carefully, case 1 and case 2 union we have to take, but these two intersection you taken, these two intersection you taken, because this one and this one you needed, but here union you have to take, so carefully you have to take that one. So that's why, so 1 union 2 equal to closed interval, sorry, here open interval minus infinity to minus 2 union closed interval 2 to open interval 4. So take this as B, right? This one union this one. Now finally what we have to take? A intersection B we have to take. A intersection B. What is A? X greater than 1 and this is B. So these two take a unreal number line. So this has minus 2 and here 1 and 2 4. So minus infinity to minus 2, so this side, and close interval 2 to 4, open interval 4, close interval 2 to open interval 4. Next this one, x greater than 1 means open interval 1 to infinity. So what is the common area? Means common values, x belongs to here close interval 2 to open interval 4. So this is our required domain of the given function, right? For that one what you taken? Under root value greater than or equal to 0. So greater than or equal to 0 means there are two cases, numerator positive, denominator positive, numerator negative, denominator negative. In that two cases common solutions you taken, and case 1 union case 2. After that this one intersection, this one if you take our required answer you will get. Okay, no? Right. So this is about the 10th problem. Next see the 11th one, that is problem number 11. So like this they given, f of x equal to log tan inverse x whole power minus 1, here to the base 2 by pi, here to the base 2, here to the base 10. So how to do this one? Once you see log of here 2 by pi, here 2, here 10. So we know that if you take this one as x, so log of tan inverse x, it has a base 2 by pi, here base 2 greater than 0. If you take this as x, this is greater than 0, and so this one also tan inverse x whole power minus 1 greater than 0, right? Now so here again if you take this as f of x, log f of x form, to the base 2 is greater than 1. So that's why how to write log of tan inverse x to the base 2 by pi greater than 2 power 0. So which one? Log x to the base a greater than k means x greater than a power k, where a greater than 1, by that condition. Now again this 2 power 0 nothing but 1. So again same condition if you apply, 2 by pi means 2 by 3.14, in between 0 to 1 means inequality will change. That implies here tan inverse x whole power minus 1, whole power minus 1, this greater than becomes less than, so 2 by pi whole to the power of 1, right? Now that implies tan inverse x whole power minus 1 less than 2 by pi. But here what is there? Tan inverse x whole power minus 1 greater than 0 is there, right? And now that's why here what we have to write, 0 less than tan inverse x whole power minus 1, right? Now, so here we can't write this as 1 by tan x, right? This is tan inverse x, this is what 1 by tan inverse x. So don't multiply these two. Now here, if you take the reciprocal of this one, so what will get, 1 by 0 less than becomes greater than, and tan inverse x, and less than becomes greater than. So this is pi by 2 you will get. So pi by 2 less than tan inverse x less than infinity. It is not possible, because tan inverse x is exist minus pi by 2 to plus pi by 2, right? So that's why for this one there is no solutions. So this is about the 11th problem. Next one, 12th problem. So take the 12th problem. F of x equal to sine inverse of log of x square by 4 to the base 9. So this is also one of the important problem. We know that sine inverse x belongs to what? Closed interval minus 1 comma plus 1. So these previous problem and this problem both belongs to inverse trigonometric functions, right? Now, so that's why what we can take, minus 1 less than or equal to log of x square by 4 to the base 9 less than or equal to 1. Now if you take this one, if you apply log x to the base a less than k or greater than k. So here a is greater than 1 only, the equality will not change. To 9 to the power of minus 1 less than or equal to x square by 4 less than or equal to 9. Multiply with 4, 4 by 9 less than or equal to x square less than or equal to 36. 2 by 3 less than or equal to mod x less than or equal to 6. By the modulus function, we know that a less than or equal to mod x less than or equal to b means, so x belongs to minus b to minus a union a to b. Otherwise, these two take like this, 2 by 3 less than or equal to mod x and mod x less than or equal to 6. Here simplify, take a number line. You will get like this, x belongs to closed interval minus 6 to minus 2 by 3 union 2 by 3 to 6. Like this you will get. Okay, no? So these are the problems. Here how many problems? 12 problems we discussed based on domain of a function which is involving the logarithmic function. Okay, no? So right. So subscribe our channel DSR Maths IIT and JE, and click the like button also. Okay, no? Right. Thank you.